Light is the name of a very narrow range of electromagnetic radiation to which our eyes respond to, or formerly known as the visible spectrum. Within the electromagnetic spectrum, there are electromagnetic waves ranging from 30 Hz all the way to 300 zeta Hz. Yet our eyes only react to a band that is from 400 nanometers to 700 nanometers. Each section of the electromagnetic spectrum is used in everything from radio communication, microwaves, and X-ray, to name a few. These electromagnetic waves travel at the speed of light, which is approximately 300 million meters per second. But this doesn't just reach the Earth and explode into different wavelengths that splash our world with color. This is because color is not a property of light. Color is a sensation in our minds in response to a particular wavelength of light. A color is then synthesized by adding together proportions of three colors known as primary colors. These primary colors determine the range of color which can be synthesized. This can either be additive or subtractive color mixing. For capturing light, we use additive color mixing, which yields the primaries red, green, and blue, and creates secondary colors which are cyan, yellow, and magenta. These all combine to form not only a color space, but also white. A color space is defined as a range of colors a camera can see. These are depicted in a triangle which shows the primaries on the corners. Capturing these wavelengths accurately will achieve the truest representation of color and thus allow us to use the color space to its full potential. Take for example the way a 3CCD or 3-chip camera uses a trichroic prism assembly to separate the light coming through the lens into its component RGB wavelengths and records the information on individual CCDs, which the processor then puts together without loss of information and reduced noise. Unlike single-chip cameras that record all three wavelengths and then interpolate or fill in the gaps, resulting in loss of resolution and lower color fidelity. Our eyes work similarly to this. The retina houses approximately 8 million color-sensitive cones per eye, which individually record the different wavelengths coming in through the pupil. The information from the cones is then passed to the brain through the optic nerve, where our brain processes the information and forms the images we see. The color space, or color gamut, is a representation of brightness and color that a system can reproduce. In 1931, the CIE, or International Commission on Illumination, defined a way of graphically representing the defined quantitative links between physical pure colors and physiological perceived colors in human color vision, and created a way of visually displaying this known as a chromaticity graph. The colors inside of the triangle are those we can reproduce. In the middle we can find white, which is more commonly known as D65 or the white point. The outside is simply predictions of what the colors would be, since there is no possible way to reproduce them. With the introduction of UHD, a wider spectrum will be achievable, which is known as BT2020. The triangle is visibly larger and can reproduce the best levels of RGB we have ever seen. This all of course comes with a set of challenges. For example, in order to get the best image, we have to rely on all systems being able to handle the information. It's difficult to see the advantages of recording a television show with a 3CCD camera if it will be viewed on small LCD televisions or CRT screens. There is of course other factors that play into this, such as resolution and bit depth. But if our screen monitor can display the truest fidelity of color, then we are a little closer to viewing content the way the content maker intended. We can also be thankful to television companies for not future-proofing their products and making us buy the newest and shiniest television sets year on year. Considering how small the visible spectrum is within the electromagnetic spectrum, it plays a major role in our everyday lives, and in the way that we produce the content that we watch. With new technology and better ways of interpreting and processing these electromagnetic waves, we are getting not only closer to reproducing content that will be closer to the way we see everyday life through our eyes, but it gives us more control over manipulating the color gamut to create better content.